Hello, and welcome back to our coverage from AWS reInvent 2018. You're joining us live from the Amazon Web Services Global User Education Conference, which we run every year here in Las Vegas. My name's Ian Massingham. I'm with the AWS Developer Evangelism team, and I'm joined by a couple of special guests live from the Expo, in the Sans Expo here at reInvent. Do you want to just quickly introduce yourselves, gentlemen?
I'm Randall Hunt. I'm just a software engineer and technical evangelist here at Amazon Web Services on Ian's team, and we are joined
by Rick Houlihan. I specialize in NoSQL technologies. I run the Black Belt team for Amazon's DynamoDB service.
Awesome.
The amazing Rick Houlihan is how I would have introduced you.
So we're going to focus on this in this next session on a quick tour of some of the purpose-built database options that AWS provides to customers. And I guess first question for the audience that we've got on Twitch is to go right back to the beginning. What is a purpose-built database, and why would developers choose a particular option?
That's a great question. Some of the things we've done over the years at AWS, we've worked with so many different customers and so many different workloads, it's become really apparent to us that workloads have dimensions. And those dimensions dictate the types of backends that are appropriate for that workload. And immediately when we started developing DynamoDB, we started to realize that there are variants, even in the NoSQL space, of all kinds of different technologies that are appropriate for various workloads. So we defined those dimensions of workloads and started looking at how can we build purpose-built solutions to satisfy those requirements.
Good, so you mentioned NoSQL there. Can you explain what NoSQL is for our audience? And maybe explain what SQL is as well, because by having NoSQL, you kind of said there is an SQL option as well.
You got to have both, right? The SQL is probably a technology most people are familiar with. This is a relational database, right? The RDBMS, this is a solution that we've been working with for 30 or 40 years, and we built everything on it, and it's been a great solution. But as we've started to work with larger data sets, and our applications become more big data oriented, and we're really starting to see that the common app these days is a big data app. And when big data comes into the picture, now we have to start doing things differently, because the relational database has difficulty when you try to scale, because the complexity of the queries it have to execute. So with NoSQL, we want to model the data to specifically support the workflows and the access patterns that are required by the application, which makes the access more efficient and more scalable.
Okay, and what kind of applications that end users make use of might they interact with that use NoSQL technology then? Where is NoSQL present in consumer or web apps that our customers might be familiar with?
And now we're getting right into the core of the purpose-built, right? So there's certain class of applications which work very well with NoSQL, and there's another class that don't.
Yep.
And the class that works very well with NoSQL are those applications that are kind of repeatable business processes. The things that we would call OLTP applications classically, or online transaction processing. This is where we have well understood access patterns, and when we have well understood access patterns, then I can tune the data model to specifically support those access patterns and make it more efficient for the system. Now, when I don't understand those access patterns, and we're talking about maybe BI analytics or OLAP, right, online analytics processing. These are applications where customers come in and they have questions that they may want to answer today but not tomorrow, or they might have different questions tomorrow.
Ad hoc queries.
Ad hoc queries. These are the types of things that are much better supported with the relational database. So that's a really good example of what constitutes purpose-built. For an analytics or BI application, maybe I want a relational database, but for something that's more representative of a common business process, which is generally speaking most of the apps we build, NoSQL is a really, really good choice.
Good, cool. What about options across the portfolio that Amazon Web Services provide? You talk about Dynamo there, and you've talked about relational database options, but what about some of the newer technologies like graph databases?
Oh yeah, that's
that kind of stuff. Where does that play a role?
Absolutely.
In the overall landscape?
And I actually do a really good session on this. I'll be giving tomorrow at 12:30, which talks in depth about purpose-built database. And we go into when does it make sense to use a graph versus a traditional key value store or a wide column store like DynamoDB. And really, it's a certain type of use case that involves traversing the relationships. A big difference between graph database and every other type of database is that the relationships are actually entities in the system. They have properties, they're indexable, and they're queryable. And so when you get into maybe recommendation engines, where I'm looking for complex query patterns like who are my friends and what did they like when they went to Paris, because I'm going to Paris, and I want to see things my friends like. That's a really good use case, because I have to traverse across the relationships in multiple steps to get that. And now the graph database allows me to make a single query. It will execute that traversal behind the API, and therefore simplifies the access pattern from the application tier.
So whenever you use a social media app where you have a network of friends, it's likely that
that's a really good use case for graph, where I need that kind of social media or social networking, friends of my friends, and trying to build connections. And generally I find with graph databases, what's really good for them is when you get into situations where, again, access patterns might not necessarily be well understood. And I need to ask these kinds of ad hoc questions. If they're well understood access patterns, we can look back to NoSQL, straightforward like a DynamoDB approach.
One of the things that I've found in the customers that I've worked with over the course of the past several years is you have your database represented in one format, but then you decide later on that, hey, I need to query this in a manner that wasn't previously supported.
Sure.
And so they end up duplicating a ton of data across this other data store in order to be able to support that type of query.
Sure.
And that's one of the things that blew me away with the graph databases, with things like Gremlin and Tinkerpop, and you can go and say in one query, hey, tell me all of the third degree connected nodes that should be recommended to me as friends based on these attributes.
Right.
Whereas if you wanted to do that in SQL, the join alone would take 2 days.
Yeah, no, absolutely, absolutely. Yeah, no, plenty of applications for graph. Root cause analysis is another really good one. We build graph dependency graphs. We can inject event streams into these graphs, and we can start to look at how these event streams correlate to our actual IT operations, right, in real time. And
we've got a question from the stream, and we are taking your questions on Twitch. So if you do have a question for our guest today, just please put that in Twitch chat. We've got moderators just off camera here that are getting your questions up to us on the studio here. So the question is from Jacob I465. He said, can you explain NoSQL in a little bit more detail? Maybe try to explain with an example how the schema might look for a database like that, or maybe there isn't a schema. Maybe that's one of the things we should talk about.
Well, that's the thing. That's actually a misconception in NoSQL that it's schemaless, right? Because there actually is schema, and there are relationships, right? All data has relationships, so we really wouldn't care about it. And so even in NoSQL, it's about modeling those relationships in a denormalized manner. And so when you think about it, if I were to look at a normalized data structure, and in my presentation I talked to a product catalog, right, where I have books, I have albums, and I have videos, and I'm joining data between these tables to produce lists of product types. Yep. So I might have a product table, I might have a books table, I might have an albums table and a videos table, but albums have tracks and videos have actors, and actors can be in many videos. So there's this mapping table that lives between these things. So what I'm doing is building a very complex data structure where I'm distributing the data around these multiple tables, and then I'm going to query that data into a denormalized view using a complex join, where I'm going to say select star from products, inner join X, and inner join Y on these dimensions. In NoSQL, what I'm going to do is take that hierarchical data, and I'm going to build either document structures or collections of items that live in single partitions or grouped partitions, so I can make simple queries or like select star from. I don't want to deal with joining the data. So one of the best things you can do if you want to know more about this is I have a great session I'm going to be doing tonight at 5:30 is design patterns for DynamoDB. We go deep into how do I take entity relationship models and translate those into a NoSQL table into very complex data structures that we'll walk through. So I would recommend that if the user here is not in the at reInvent, definitely take a look at that YouTube video.
Yeah, so we should say that all breakout sessions from reInvent that we're going to be talking about quite a bit over the course of the week will be available on the AWS YouTube channel shortly after the show finishes. So if there's something here that piques your interest that you want to learn a little bit more about or dig into in more detail, then just visit us on YouTube on the Amazon Web Services channel. You'll find there'll be well over 1,000 sessions there after the course of a few days for you to take a look at all of the latest services, as well as Rick's deep dive sessions that he's talked about a couple of times already.
Rick, is this your fourth year giving that
year.
talk?
Absolutely, and this year I'm going to be diving deep on very complex relational modeling.
Within Dynamo.
Yeah, within Dynamo. We're going away from the basic design patterns and going really into the core of what we do every day.
I've got to tell you, I watch almost every reInvent session, and I rank them, and I put a little GitHub article up afterwards, and I say these are my favorite sessions, and yours has been in there, I think, all 4 years.
I appreciate that. That's very good.
It's
That's
just
very
really fascinating stuff. One of the things that I think people don't realize is when we talk about denormalization and changing from relational form to non-relational form, you may have taken a database class in college, and you might have heard of this thing called normal form. This is back in the 70s, right?
Yes.
When they kind of decided that this was the way to represent data. And you ended up creating, as you said, these incredibly complex mappings. You would have tables that would exist just to map a foreign key from one table to a foreign key from another table, and then you would have another table next to that table to specify attributes on that relationship.
Right.
Whereas in a graph database, for instance, if you want to specify the attributes on that relationship, It's just the edge between the two nodes, and you say whatever properties you want to put in there.
Yes.
It's really a powerful construct, and the underlying patterns, a lot of the core code, is somewhat similar. It's just
similar.
It's exposed in a different manner.
That's the crux, right? It's about the data doesn't change. The relationships between the entities, the entity relationship model, it is still the fundamental construct of the modern application. We have to define that in NoSQL, relational, graph, it doesn't matter, we have to define that. It's how we represent that model in the data store changes, right? And so that's, getting back to your point of when we decided to do relational, right? We did relational in the 70s for a really good reason, because storage was extremely expensive, right? And actually back before the relational database, we had distributed document stores, right?
Right.
We had index servers, and people would query the index servers and go get the document stores, and so it's almost like NoSQL is not new. NoSQL has been around since the 50s and 60s.
Well, even Edward Pick was the first person to create the NoSQL database, right? And for the Apache helicopter parts or something.
Yes, exactly.
He was a cool guy. He used to like hang upside down on his back and like type into a giant CRT monitor. It was.
Yeah. So I mean, this is the thing. So when and it really hit me. When I started to think about some of my past experience in the early 80s, I was going through Macworld at Moscone Center, and I saw you might have heard me talk about this before, but I saw what appeared to be a truck transmission in the middle of the conference room floor. And I went up, well, why is there a truck transmission here? And it wasn't a truck transmission, it was a cross-sectioned hard drive from 1974. And it was 4 megabytes, and it had a little sticker on it that said MSRP $250,000. So when you think about it, now in 1974, obviously we weren't storing a lot of data on magnetic disk, but if if there's a good reason right there, why did the relational database become the database of choice? Because it maximized the most expensive resource in the data center, right? Space efficiency, right? And so now today we go back forward 30, 40 years, and the most expensive resource in the data center is the CPU.
Yep.
I pay pennies per gigabyte, so maybe it's time to start reanalyzing.
Maybe this is part of the answer to this question. I'm probably going to butcher this handle, okay, because it's really hard to pronounce, but this I think is from Opasnik Backlin. I hope that's okay. What are the disadvantages of a GraphDB? Is it the fact that you end up storing data, numerous copies of all of the attributes? Okay. Is there something else which is a disadvantage using this GraphDB-based approach?
So probably the biggest disadvantage of graph databases would be the latency of complex queries. Yep. So as we traverse multiple relationships, it's not like it's free.
There's no concept of an index, right?
That's correct.
Like
and there can be, but the bottom line is, as I start to traverse the nodes and I start to go through multiple edges, the query cost becomes more and more heavy on the system. Yeah. And so maybe that's when we start to look at, maybe what I want to do is start to go with pre-computed types of graph aggregations, and this is a very valid pattern that we use, and we've used in relational world, we use in generic NoSQL world, but pre-compute your graph queries and tag the edges with those results, so when people come back and say, hey, I need this person, and I get that person record, it also has his friends, the friends of his friends, and the things they like.
That's probably a common use case in social networking where you've got really
very
large
much
graphs.
so.
Right?
Lots of common applications built that way. Yeah.
Okay. Question from these. JCBU38. Can you talk about what use cases are not good use cases for NoSQL? I think
sure.
You've talked about this
we talked a little bit about it already, but it really comes down to, do I understand the access patterns? Are they very well understood access patterns? If they are, then it's a NoSQL application, or it could be. And that's really what NoSQL is built for. It's OLTP at scale. And one of the nice things about OLTP applications, this is the common business process, and it's 90% of the applications that we build today are to support common business processes. Things like Amazon's shopping cart. When you click the order button, guess what happens? The same thing every time.
Yep.
If I understand that access pattern, I can use NoSQL. If I need something that's going to be more of a ad hoc query, as you mentioned, something that is, I don't understand what the question might be tomorrow, because it's going to be a business analyst who's interested because of some big market event, he wants to see something that he's never seen before, then that's a much better application for a relational data store, and you could use NoSQL to back something like that for a decision support system or a large scale data lake. But if you want high performance, low latency access against ad hoc queries with access patterns are not understood, that's a relational case.
Is there a pattern for managing data lifecycle in NoSQL databases with a TTL? Where,
oh, sure, absolutely.
We're interested in our order history on Amazon for what, 30 days maybe?
Yes,
and
after that things age out.
Immutable, and we're probably not going to return to it that much. So is that a pattern that a lot of customers adopt as well?
Absolutely, it's a very common pattern, and DynamoDB gives you a lot of really neat tools for managing that data lifecycle. We have a TTL attribute you can set on the items on the table. It's a Linux epic timestamp in seconds. If it exists on the item, then that item would be TTL'd or removed off of the table at some point. And we also give you a technology called streams, which is kind of the running change log of DynamoDB. Every write operation against the table is going to show up on the stream, which gives you the ability to then call a Lambda function and trigger that Lambda function to read the stream, or even build up a static stream reader in EC2, and then manage the data lifecycle. Do I want to export that data to S3, or roll it up into some sort of archive, but it's up to you. So yeah, absolutely, a lot of tools that are there for that.
One of the really cool things I've found with DynamoDB and streams and even going further afield when you talk about purpose-built databases is things that we don't think about as databases. Like S3 we think of as kind of like this key blob store, but with tools like S3 Select, you can go out and actually query individual objects, and it's just regular SQL that you're used to writing. Right. And then in Kinesis, you have Kinesis Data Analytics, which is again just regular SQL that you're used to writing, and you can work on streaming data.
Yes.
And you go, one of the best sessions from last year that I thought was the DynamoDB session with Snapchat.
Okay.
And what they did is they analyzed their access patterns, and we have the TTL feature.
Yes.
And they decided that, well, we don't want to use the TTL feature. Well, I think they did end up using it in a different way, but they decided that because these stories only last 24 hours, we don't want to replay our entire workload exactly 24 hours later. So what they did is they started setting timeouts over 48 hours, and they just changed one little attribute in the object to make sure it didn't show up anymore.
Sure.
I thought that was a really cool
hide
use case,
the data.
and they just thought about their access patterns, and they were able to find the exact perfect way to represent their data.
And that is a principle process in NoSQL development. It's actually the reverse of a relational database development, right? In relational data, I model the data, I build a normal form, we load the data in there, and then we can talk about how to query it later, and we can add indexes and all this. But in NoSQL, it's the opposite. I need to understand those access patterns in detail. So the first step is to, after I define that entity relationship model, is okay, now how is this application going to access that data so that I can then structure it correctly? Because what I do for one application might be perfect, and I can walk into another application using very similar data with different access patterns, and it would be a disaster. Mm-hmm. So that's kind of the fundamental process difference between a relational app and a NoSQL app.
And we even have Elasticsearch full text search now, which is another database really. Sure. And I think when people think about databases, when they haven't been exposed to this stuff before, they're thinking, oh, Postgres or MySQL or Oracle or Microsoft SQL Server or MariaDB or one of the other engines. And they're not really thinking, databases is just where my data lives, and I can create however I want. And you talk about the BI workloads, you have Redshift, and one of the other differences between NoSQL and relational is I think, with the exception of Aurora, relational databases have a little bit of a harder time kind of doing the horizontal scale out. They're a little more designed for that vertical scale out.
Oh, there's no doubt about that. That is the where the relational database breaks is at scale. So this is why I say all the time, OLTP at scale. That is the sweet spot for NoSQL.
Right.
There's certainly plenty of applications that are not scaled out apps that can benefit from NoSQL, from spiky workloads, on-demand use cases, especially from a managed service like Dynamo, which has elastic capacity that you can turn on, turn off when you don't need. That is a huge advantage. But generally speaking, applications that are scaled out for OLTP, that is the absolute sweet spot for NoSQL technology.
You throw more compute at the problem, and it goes back to your point earlier about back when the storage was the most expensive
That's
part.
Right.
You wanted to optimize for storage, and now that storage is cheap, it doesn't matter if you're duplicating the data in a few places. You can scale out to as many nodes as you want.
That's right.
And provide the best performance to all of your
and
users.
you're optimizing the read pattern, which
and
is
you're
generally
optimizing for durability as well by having that data on multiple nodes, so you're creating something that's fairly tolerant there as well,
That's
right?
That's
so we only have a little bit of time left. I'm just curious, what's going to happen in the next 5 years? What do you think the next part is?
What is the next part? That's a good question. I think that we're going to continue to develop more purpose-built solutions, right? We have certainly some exciting announcements that I expect to see tomorrow. I wish I could talk about right now, but I can't. Actually, I would emphasize that I think the world starts to become more specific, right, with the databases that they're using. One of the things about some of the solutions I'm seeing out there, where it's like try to do everything with one API, you know what, flexibility is fantastic, but flexibility comes at a cost. And that cost is dollars in your pocket, because it's efficiency of the system, and it's the amount of compute resources that you have to throw at the problem. So it's great that you can think about things like, I have one API, it does everything, but the reality is that you're going to be paying for that flexibility. So purpose-built, as data scales, is going to become the way. I absolutely believe it.
Great, excellent. We'll wrap it up there because we're out of time. Thanks for joining us from AWS reInvent. We'll be back in around 5 minutes with our next session. Thank you, Rick.
See you soon.
Thank you.
See you soon.
Thank you.